In the ever-evolving field of computer science, understanding the concept of computing paradigms is essential. These paradigms represent distinct approaches to computing, each offering unique methodologies and applications. By exploring the various paradigms, tech enthusiasts can gain a deeper appreciation of how computing technologies have developed and how they continue to shape our digital world. A computing paradigm is essentially a framework that defines how problems are to be solved using computational methods. It encompasses the principles, theories, and practices that guide the design and implementation of computer systems. There are several key paradigms that have emerged over the years, each contributing significantly to the field. The first paradigm to consider is the imperative paradigm. This traditional approach is based on the concept of sequential execution of instructions. Programs written in imperative languages, such as C and Java, specify a sequence of commands that the computer must perform. This paradigm is closely aligned with the von Neumann architecture, where programs and data are stored in the same memory space. It emphasizes control flow, using constructs like loops and conditionals to direct the program's execution. Next, we have the declarative paradigm. Unlike the imperative approach, the declarative paradigm focuses on what the program should accomplish rather than how it should achieve it. This paradigm includes sub-paradigms like functional and logic programming. Functional programming, found in languages like Haskell and Lisp, treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. Logic programming, as seen in Prolog, involves defining rules and relationships, allowing the system to infer solutions based on given facts. The object-oriented paradigm is another pivotal approach. It organizes software design around data, or objects, rather than functions and logic. Objects are instances of classes, which define their properties and behaviors. Languages like Python, Java, and C++ are prominent examples of this paradigm. Object-oriented programming, OOP, promotes code reuse through inheritance and polymorphism, making it easier to manage large and complex software projects. The event-driven paradigm is especially relevant in the context of graphical user interfaces, GUIs, and real-time systems. In this paradigm, the flow of the program is determined by events such as user actions, mouse clicks, key presses, or sensor outputs. Event-driven programming is prevalent in environments where responsiveness and interactivity are crucial, such as web development, JavaScript, and embedded systems. In recent years, the parallel and distributed paradigm has gained prominence due to the increasing need for high-performance computing. This paradigm involves breaking down tasks into smaller subtasks that can be processed concurrently, either on multiple processors within a single machine or across multiple machines in a network. Technologies like Hadoop and frameworks like MPI, Message Passing Interface, facilitate the development of parallel and distributed applications, enabling efficient handling of large-scale data processing and complex computations. Finally, the quantum computing paradigm represents a frontier that holds the potential to revolutionize computing. Quantum computing leverages the principles of quantum mechanics to process information in fundamentally new ways. Unlike classical bits, quantum bits, qubits, can exist in multiple states simultaneously, allowing quantum computers to solve certain types of problems exponentially faster than their classical counterparts. While still in its early stages, quantum computing promises breakthroughs in fields like cryptography, material science, and complex optimization problems. Understanding these computing paradigms provides a foundation for appreciating the diversity and complexity of modern computing. Each paradigm offers distinct advantages and is suited to different types of problems and applications. As technology continues to advance, new paradigms may emerge, further expanding the horizons of what is possible in the realm of computing. Explore more about these fascinating topics by watching our recommended videos in the associated playlist.